Okay, I've got both sides of the half nut in. I want to explain something, draw a little picture for you while I still can, because there's no way I can get this on camera. The way this mounts in the machine, there's a machine surface here and here, which goes to a machine surface in the same places on the machine. In the middle, it's a rough casting. The reason why is because when these half nuts open, they protrude out. That's the reason why it's not a bearing surface all the way across, because inside the machine, see if I can draw you a little sketch. It looks something like this. Okay, so there's a bearing surface here that mates with here. Bearing surface here that mates with here. In the middle though, there's nothing. You can see it steps out. It looks just like this inside, but I can't get it on camera. It's just too dark and too small. So when the half nut opens, there's somewhere for it to go. It doesn't hit against anything. This is why I didn't put grease on this face, because nothing ever comes in contact with it. There's no point. So I just wanted to explain that and draw a little picture. Okay, so the next step is I'm going to put a little grease around here, and then I'm going to start putting more pieces on. I know, this is so exciting to watch. Okay. Wipe my hands clean. And now, this goes on. This is a handle, and this goes like that. This is a ring gear. You can see the teeth there, and this slot is where that indicator pin goes. I'll show more of this later. But this handle, when you turn it, moves the little gears, which moves the half nut in and out. So this slides down here. You got to make sure the half nuts are in when you do this, otherwise it won't clear. Just like that. Now's when it gets a little complicated, because come on, there you go. This goes on here, and it only goes well in one way. And I don't know if this will show, but there's what's called a witness mark. You basically take a center punch and punch two holes next to each other in something you're disassembling, so when you go to put it back together, you can reline it up just like it was when you took it apart. In the machining world, this is important because a lot of times things only go one way, and that's the way it is. Now that lines this up to this. The problem is you have to get these gears lined up in this ring, so that way when you turn it, both of these move at the same time. I'll give you an extreme example of how this can go wrong. You've put this in. Cool, it's happy. Let's put it together. As I mess everything up. Okay. Trying to demonstrate a possible mistake and I make a mistake. How about that? So you've put it together and you're ready to put it on the machine. Problem is, didn't check to see if these half nuts were aligned. So when you go to turn it, one will be out, one will be closed. So what you have to do is make sure and turn these gears. I'm looking at the half nuts. I know they're not on camera. They're both all the way in. Then you put this on. This is one of them things where everything has to be just so, otherwise it will never work. You know, I wonder if it would help if I put a little oil on there. Just maybe. Bet it goes smoother now. What do you think? Man, this is finicky. It's like 6 different parts. They have to be just right. I think I got it now. This slides up over, again, having the witness marks in their places. Now I'm going to put in a couple screws and hope that I have this thing put together right. Now what I was trying to line up, you see how the dowel pin is at one end of the little track it goes in, how the gears are at one end of the little teeth they sit in. Reason why is because the half nuts are at one end of where their travel is. It'll be easier to show this in just a second once I have all the screws in. Okay, 2 screws, I'll give it a test. Cool. Half nuts retract. Half nuts go together. Awesome. And you see how there's one gear tooth here that's empty and one here that's empty, and how that pin is in the same place. And I'm sure it doesn't show, but looking down this hole, the half nuts completely have retracted so something can go through there without hitting them. All these things have to be just right for it to work. So that's what I was spending so much time trying again. It has to be just right. Now that I know it's right, I'll finish putting the screws in. After all reasonably snug, I'll go around one more time and tighten them up good. See how that one popped loose a little bit? This plate pushed down, this handle pulled up. That's why you always tighten them all together. Never tighten one screw. Especially in a bolt pattern like this. Never tighten one all the way. Always get them all snugged and go back. Snug them a little more and then go back and tighten them all the way. That rule is true of just about anything that's made of metal. Okay. Runs smooth. Everything's lined up like it's supposed to be. Awesome. Now, I'm not going to grease these gears. Couple reasons for that. These are not high stress gears. If there's more than a pound of force on these, something's horribly wrong. And also these are exposed. It's not like all the pieces inside this where I can't get to without taking the whole machine apart. So I can always just spray a little oil on there and it'll be fine. Now on my bigger gears that actually drive the spindle, I am going to use grease because they're under much more load than these are. But for these I think it'll be fine just to use oil. And now I'm going to flip it over. On the back side, I don't know what these numbers mean, they're just there and I painted them in just to make them pretty. It says number 11 and number 12. I have no idea. There's a lot of random numbers on the machine like that. Anybody out there in the internet world knows what it means, please let me know. Okay, so the next step is this thrust bearing. This bearing is what takes all the pressure that comes up through the tool bit, through the shaft, through the spindle, excuse me, and ultimately into the half nut when you're using auto feed. This bearing takes all of that, so it has to be pretty big. And here's the bottom raceway, and you can see a little trench it's carved in this big washer over time because all the pressure that's on it. So I'm going to put a little bit of oil on here. Oil everything. It's just a good general rule. Move it around a bit, spread that oil. Now this bearing is going to be greased because, like I was talking about, those gears, those are low demand, meaning they don't have a lot of pressure on them. This is a thrust bearing. It has a lot of pressure on it, so it's getting grease. Also, another reason for using grease is, as you can see, it stays put. Oil will just run off. That's another reason why I'm using grease on my gears as well. So that way when I spin this machine up, it doesn't spray paint the walls with oil. Construction of this bearing is very, very simple. It's just, I'll draw you a little sketch. Easier that way. It's just a ball. Then there's two plates of steel. One here, and the other side here. And what holds that ball in place is a chamfered facing the ball. Like this, like with a countersink. So that way these holes are smaller than the ball, so that way the ball is held captive in there, it can't go anywhere. Then around the edge, right there, and right there are rivets that they riveted the whole thing together with. Very, very simple ball bearing. But it is 100 years old. And I'm sure for the time this was probably advanced technology. The cool thing is, though, it still works. Okay, I can't even grab it now, it's all slippery, which is good. So there we go, all greased up. I'll bring this back into the picture, and we we just carefully set that down. And now for the top. I'm not really sure the purpose of this, maybe to reduce wear, but you see there's a notch right there. On the casting that this thing goes into, there's a little key that keeps this from rotating. The only reason I can think that was done was to keep this spinning against the casting. Other than that, I'm really not sure why that's like that. And the key for this is relatively small, so it's not like they thought it would be under a lot of load or a lot of stress. It's just to keep it from spinning. It's interesting. I'll show that key later when I install this thing. Now the top side, I'm going to put just a little bit of oil. And the main reason for oiling the top, honestly, is so, again, in 20 years or however long when I take this thing apart to service it, clean it up, whatever, I won't have to fight with it to take it apart. It shouldn't stick together or rust, or at least that's the intention. Wipe all this excess grease off of here. Oops. I wiped off all the excess grease only to remind myself this thing needs grease. Dummy. Duh. Oh well. This is my first time assembling anything like this, so I'm learning as I go. Okay, we're pretty well done here. Now I'm going to go back over to the machine and I'm going to install this thing. Alright, I'm going to go over to the machine, put this on. Be back in just a second. Okay, we're over here at the drill press, which I've stood upright now. This is the very top of the drill. This is where the half nut goes. The bottom of it goes here, top goes here. Now you remember earlier I mentioned there's a little key slot that keeps the top part of the bearing from rotating. That goes right here. And here's the little screw that holds it in. And there it is, a washer. It's being a little stubborn. There it goes. I think I got a little bit of paint in the threads. It's okay, it's going smooth now. Now that it's close, I'll go ahead and put the key in. There it is. Just about an 1/8 inch square piece of metal, maybe 5/8 long. It just goes right there. And when I tighten the screw, it pushes on the washer, which holds that in place. There we go. Now for the fun part. Lifting up that half nut into place. Hold on, let me put my screwdriver down. Okay, I'll apologize in advance if I bumped this tripod. I'm pretty close to it, and I have clamps hanging on the tripod for easy access because I'm standing on a step stool at the moment. So here we go. Wobbling it back and forth a bit to get it to go up in there. Now spin this around to find that slot. There it is. On the top side goes a spring washer. And on top of that goes this ratchet wheel. This is what the auto feed is powered by. There's a little pawl that pushes on this ratchet, which pushes the half nut. Then pushes the lead screw, if you want to call it that advances the quill feed. Oh, and by the way, there's a oil hole in this. Now, since I only have 2 hands, I have the wonderful invention of some quick clamps. Just put one on each side. I also use these to compress that spring washer, because it needs to be under tension. Okay, breathe a sigh of relief, wipe off my hands, and then we'll put in the 2 set screws that hold that top wheel on. And you can see here it says closed, over here it says open. What that means is if you turn this hand wheel this way, it closes the half nut, which engages the lead screw. If you turn it that way, disengages the half nut. Now, a nifty little trick I have discovered. And I learned this through dry fitting this whole thing. I put it all together when I first got it just to make sure everything was here and it all went together properly before I went through all the effort of restoring it. One thing I discovered is the bolts, the set screws for this wheel, have 3/8 square heads. I have a 3/8 inch socket extension, which works great because they're up here in this confined space. Can't really get a wrench in there. I just put that in there and screw it in. I'm going to put a little bit of oil on this first. I did the oiling off camera. I just don't want oil dripping all over my tripod. Okay, it's finger tight. Now I'll do the one on the back side. And here I have a 3/8 wrench. I'll stick that on the end of this extension. Wrong end. There we go. Own little homemade wrench. Didn't want to come off. Now I'll go finish snugging up the other side. And I'm dropping tools on the floor. Okay, it's good and snug. Now I should be able to take these clamps off and nothing will fall apart on me. I'm going to stick my hand under here anyway. There's closed. There's open. Awesome. And I'm looking down the hole to make sure that is working properly. And it is. Cool. It's a little stiff, but that's because I haven't oiled it yet. You may have noticed I didn't oil any parts in here. That's because it has the oil hole that I showed you. So, grab my oil can and take care of that little problem. Run away, oil. That should be a little smoother. Oh yeah. Freeze right up. Now I think, I don't know this for sure because I'm not the one that designed this thing. What the spring washer is for is helps eliminate any slop in the half nut. Also, what I think it's for, and I just discovered this honestly, is it provides resistance so when you turn this to move the half nut, it's not applying enough force to turn the whole thing, which is pretty cool design. Cool. Just playing with it to get that oil all spread around. Same thing for the greasing this bearing down here. Get all spread out and happy. Okay, I'll go ahead and turn you off and come back for the next part.